Hello everyone. I'm talking about PCI module T520 about girder stability, introductory material, and hangy girders. So let's. I'm talking about the whole module. So let's go with the importance of lateral stability. So optimize the girder shapes allow longer span length. Plus, these girder shapes have improved stability characteristic like wide top flange and wide bottom flange. The stability engineer is defined as a person who is responsible for their things like transportation the girder from one place to another place, like one point to another point. The critical phases in the life of the girder, like lifting, storage in the press dressing yard, transportation to the site, and the erection and the construction. Last stage is the construction. Okay. So criteria for girder stability. So for that, it's like a define, assume, design, and construction load. Identify assumes material properties, specific tolerance for constructionista, and the established stress, limitation, and overall factor of safety. So assume design and the construction loads are like three are over there. So first is permanent load. It's like regular load like a dead load, structure components and press stressing forces, grips and shrinkage. There is a spelling mistake. Oh, okay. Transit loads like dynamic loads, centrifugal force, and construction live load. Those are considered and the transit loads. The last one is environmental load. So in this one, it's consists about wind load, thermal effect, and seismic load as well. So this is kind of important when you transfer the girder from one place to another place, especially when they transport the dynamic load, centrifugal force, and construction live load will occur. And the environmental loads could be like wind load and thermal effect and seismic load sometimes occur. So the dead load of structure component, the actual dead load depends on the material, definitely how those girder made from. So material used in the fabrication of the girder and the construction of the bridge. So press stressing force during the handling, it's like press stressing force resulting in the distribution of the stresses in the girder that must be accounted of when determining the cracking resistance and ultimate strength of the fiber. Loss of the press-tracing force must be consist at each stage of the life of the girder. Like for scripts and shrinkage, this can result a deformation that must be considered in the analysis of the girder stability. So dynamic loads, so loads of effect are usually as issue at high speed with small super elevation like when the dynamic loads will occur. So load effect are usually in the like issue at high speed. Sorry, when the truck is moving very high speed and there is a small elevation over there. So it happen that could be happen. The dynamic load will occur on this type of scenario. So for the centrifugal force, this force is considered for the stability during the transportation around the curve. So when the truck or like a big truck carrying the girder is running over the curve, at that time the centrifugal force will occur on the girder. So it has some effect or not. The third load is like a wind load. So wind load are generally are different by various geographical location. So this may reduce This may reduce due to the short time in individual girder are exposed to the wind during the construction. So wind load is like different. It's totally different based on the location. Like when if you are in the like high wind area, you definitely hit the high wind. So it definitely affect on the girder as well. But if you are not in the windy area and the weather is really good, then you don't need to worry about the wind load actually. And the distance is very short, so you can neglect this load. Special girders should not be lifted in high wind condition. Check the transportation route for possible unusual wind condition. So if the thing is you need to transfer this load from one place to very long distance and very high windy area, then you could ask for the wind possible condition for that route. The other loads, it's like a seismic loads. So in this one, we have like only considered for the seated girder in the structure. Also very dependent on the location. Definitely, if your location is nearby the tectonic plates, so definitely there is a high chances of the occurrence of the earthquake anytime. It's a high altitude. So if you not nearby the plates like tectonic plates, so you're safe. So you can it will be easy to remove this load as well if your travel distance is short and geographic location is flat and not in the earthquake zone. So next slide will be the stability of hanging girder. So in this one, it's like it's actually depend on the roll axis. Is it the line that connected to support point of the girder about which the girder can rotate. So sorry to forget. All girders have a slight imperfections. Yeah, it's just the two things. Like the weak axle component causes the lateral deflection, which increase the tilt. You can see in this diagram. And for equilibrium resistant moments, for the equilibrium resistant moment and active moment must be equal, like showing in this equation. So for the equilibrium angle, this is the angle used to find the lateral moment in the girder due to self-weight. Is the equation you can use for that. And the second one is cracked section. When the crack hits the beam soften for that based on the equilibrium post cracking should calculate by this equation. Like if anything happen like cracking or anything, this equation we can use for like post cracking should calculate by this equation. Wind on the hanging girder. So it's depend on when we need to calculate the wind. It's totally depend on the situation. So these two cases for the wind loads. So one you can see the equilibrium condition where the wind load increase rotation and the decreased lateral deflection. And the second condition is equilibrium condition where the wind load decrease the rotation and increase lateral deflection. So when wind increasing rotation and decreasing the lateral deflection, at that time we use this equation. So using small angle approximation that cos theta 11 equal to 1. And for the wind increasing rotation, like decreasing lateral deflection, special case of the wind causing tilt in opposition direction. In these cases, the equilibrium angle of tilt becomes negative and the quotation must be modified to account for the reverse tilt. These cases are easily identified by EI plus headwind equation. All right, this is the module. This is PCI module, the T520. It's the slides for that. Slide girder stability introduction and material and hang girder. All right. Thank you.